Thanks for joining, everybody. My name's John. I'm the senior hydrologist at the Weather Service in Burlington, and happy to talk with you all today. I've been there about 25 years, so as a lead forecaster for a long time, and in the hydrologist role for a number of years. So happy to be here.
And then Dean.
Hi, John. I am Dean Pierce. I am a senior planner, work with Sean mostly on water resource related issues. Also work closely with Lindsay and Ellen and Chip in various capacities, as well as Sean. Nice to meet you.
Nice to meet you, Dean.
I'm Lindsay. I'm the director of the Missisquoi River Basin Association. So as Dean mentioned, work with these guys pretty regularly. I'm joining from the coast of Maine today, so it's lovely behind me.
I'm jealous.
It's very cottage, backdrop. So very nice. So I'm Ellen Fox. I work with Lindsay at the Missisquoi River Basin Association. I'm a project manager. So work on lots of floodplain and corridor issues all the time.
Okay, well, great.
And hey, everyone, I'm Chip Sawyer, Director of Planning and Development for the City of St. Albans.
And I'm Sean Coleman, Senior Planner with Regional Planning.
Okay, so I guess what I can do is I can go ahead and share my screen here, and then we'll go ahead and get started. I'll make sure everybody can see that. Let me just hit share, and we'll do a window, or I'll just do my entire screen. Can everybody see the presentation now?
Yes.
Okay. And I'm going to advance one slide and just make sure you can see me advancing, because sometimes you never know, weird things happen. So again, this is going to be flood inundation mapping training for NRPC and MRBAVT. That's a tongue twister. And I was talking to Sean earlier. I may have an opportunity to come back and talk to some other folks in the emergency planning and public safety in the area on a future date, but I'm happy to talk to you about this material today. Let me just go to the agenda. Did everybody see me advance the slides there?
Yes.
Okay, great. So this is a brief agenda. We're going to talk about the importance of flood inundation mapping, which I'm just going to call FIM from here on out. FIM overview, just a little bit about the FIM that you're going to have access to. Then as we get toward the end of the presentation, I'll talk about FIM and how it works with what we call IDSS, Decision Support Services, DSS. So in a flooding situation, how am I working with town planners and emergency managers to convey flood information? FIM is just one of those layers. We've got a lot of other services, obviously warnings and things like that. And finally, some tools and resources for you to how to access this stuff. I'm going to show you here, but I'm going to have some other links that you can refer to back on the recording. So let's talk a little bit first about the importance of FIM. So it kind of transforms the way we communicate flood impacts. We've always had flood warnings that alert on your phone or an EAS scroll on your TV, or you see it on the web, or the TV news guy talks about it. But this is going to add another layer on how we protect lives and property and get the public safety message out there, and we work together during times of high water. So this is just kind of a brief image of kind of a then versus now. This was a nursing home on the left during Hurricane Harvey in Houston back a number of years ago, where these people did not realize they were in the floodplain and got flooded. Luckily, no loss of life occurred at this facility, but there was a period of time where these occupants were sitting in floodwaters until they could get rescued. Whereas now there are situations, if you're more informed about where your structure lies and what actually it looks like on a map, you can have better awareness of whether you may flood or not. And so this is a case where the residents in Florida, I think this was during a hurricane passage, maybe Ian or something a few years ago, asked to be evacuated because they knew they were in the flood zone. So basically, we're just putting water on a map. You're going to be able to visualize, and I know a number of you are familiar with the FEMA firm maps and flood risk maps. This is not that, and I want to make that distinction. This is inundation based off of what either one, a model is telling us, or two, what our official forecasts are telling us at our places where we do have official forecasts, at like Swanton and East Berkshire on the Missisquoi, or Rouse's Point up on Lake Champlain. Okay, so let's talk about FIM overview. This is kind of the breadth of what I'll be talking about in the next half hour or so with you. All of this FIM, flood inundation mapping, is driven off the National Water Model, which has been around for 15 years at least, under development, some cases operational. It's a continental scale operational hydrologic modeling system designed to enhance the flood warning capabilities and forecasting capabilities. So it provides high resolution stream flow and hydrologic forecast across the US. It provides real-time forecast data for flood forecasting, water resource management, and hydrologic modeling. And the key outputs include stream flow predictions, inundation mapping, and flood forecasting. I'm talking more here about the inundation side of it today. So it's a huge rollout over a period of 3 or 4 years. And this is just kind of a map showing how it rolled out. So in 2023, we had some test areas that rolled out live with the FIM services that I'm talking about today. Some down in Texas and Louisiana, and then close to home here, up in Southern Tier, New York. And actually, if some of you know this, the National Weather Service in Albany actually covers the southern 2 counties in Vermont. That's their kind of jurisdictional area. We cover the rest of Vermont, but Albany covers these far southern counties of Bennington and Windham, and they actually went live with these services a few years ago. And then last year, we did another tranche of rollout up to 30%. So you see what kind of filled in. This year, come September 2nd, we go live with the 60%, and we're lumped in with other parts of the nation. And then the following year, 2026, the whole nation's filled in. So they kind of did it in different rollout periods. So as we've incorporated this national water model into some of these services, it's an evolving capabilities. So on the left, we've, for a long time, and some of you may be familiar with going to our rivers page and looking at the river gauge data, we've had these river gauges, and some of them are forecast points where we have forecast for, some of them just show you the observations and that's it. We've had this forever. This is the interface that's been, over the last year or two, has been the new interface we've been rolling out with. You click on this, you see the river gauge, you see what the flow is. If it's a forecast point, you can see what the forecast is. So it's about 110,000 river miles, and we're going to have FIM for that coming out. Now, when you roll out the water model, in addition to that, it's mapping for 3.4 million river miles. So you got to think the complexity of computing the resources for all of this. So you're mapping everything from the Missisquoi River on a larger scale, or Lake Champlain, all the way down to something small like Rock River at Highgate Springs, or the Jewett Brook in St. Albans, like little guys that don't have some of them have a little gauge on them, other ones may not even be gauged. So you ask yourself, how do you do that if you don't have a river gauge and, for example, a rating curve, which relates stage to CFS flow? Well, they do it by something called this hand method, which is the height above nearest drainage. And basically what they do is they get a digital elevation model, which is normally derived from LIDAR, USGS, state level LIDAR, or private LIDAR data sets. And they basically use a hydro conditioning scheme to convert that to a relative elevation model. And you basically grid it out, and then through this relative elevation model, to make it simplified, it maps what grid cells are higher or lower than the adjacent grid cells. And so that's kind of how they do it. I could talk to you an hour just about this hand method. I do have some references I can leave with Sean here, handouts. And then if I do ever talk to you virtually, or I can follow with Sean, and I can give you the electronic links to those documents. I brought these just because I didn't know if anybody was going to be here. So this is kind of just an animated way to look at it. It grids it out as you go from the DIM to the RIM, the regional elevation model, and then it maps the relative elevation of these grid cells to one another, and then it normalizes it. And it's doing this across the entire nation. That's how they're doing it right now. They're looking for even further refinements to the hand method and going with more even precise methods. So once you do all this hydro conditioning and normalizing of the data, you get down to a point where it's this, as you see it on the map. And the zeros are the low points, and the 17s, 18s are the high points. And so water falling on that grid cell will flow into the nearest lower grid point. So a 4 is going to flow into a 2 and a 1 or a 3, and 0 is the baseline. That's how they route the water, because they don't have a river gauge to measure anything by on these little creeks and streams. They certainly don't have a measured rating curve like they do, like the USGS does at Swanton and East Berkshire, or even the smaller gauges where a technician goes out there several times a year and measures that channel. This is Anywhereville, USA, how you're doing that. So that's kind of the approach on how it does it and calculates. But as you can imagine, there's a lot of high degree of calculations and computer resources to do this. So once they do that, they kind of have a synthetic rating curve they make. We have measured ones, like I've said, for the river gauges, but these are basically stage versus discharge. It's a common relationship used in hydrologic modeling. So you estimate basically the water depth or the rise in water for a given stream flow, CFS. And it's pre-computed at about half-foot intervals for each reach. There's a couple of limitations. I'm going to get into a lot of the strengths and limitations of the way we do this in a minute. They don't update dynamically with changing river conditions. As you know, if you get a big flood, like the July 23 or 24 floods, and you blow out a big flow through the channel, it'll have slight geomorphological changes in the river channel. That's why those USGS technicians go out to their actual gauges and measure those 3 or 4 times a year, because they need to know what's changing. Here, unless you get a new LiDAR data set, you don't know what is changing. So that doesn't change, but it's what you have to do where there's no measured stage discharge relationships. So there are many advantages and there's some disadvantages to doing this, of course. So the advantages, you have computational efficiency. You can do it anywhere. You can scale it down to half meter increments, half-foot increments. You normalize the terrain, which makes it easier to route the water downstream. It can be used to improve flood prediction. You can see the high flows and inundation on these creeks where you didn't be able to see that before. And you can integrate that into flood forecast services. It's simple, easy to access and to visualize. And you can have flexibility for a lot of applications. You can think off the box, top of your head, okay, I've got flood inundation for a stream I never had a gauge on before. What does that mean? I can think of a lot of things you can apply that to, both environmentally or from a public safety standpoint, if there's a problem with high flows. Of course, there's some limitations. And I'm going to go through a couple of them here. The top one, missing bathymetry. Bathymetry is basically measuring the channel bottom of a stream. Well, LiDAR can't, unless you're using green LiDAR, which they're going to be moving toward in the next 5 years. But right now, traditional LiDAR, you just see the surface of the water. Looks like it's a tabletop. Have you ever looked at LiDAR before? So you don't have that bathymetry. So when you first start to rise the creek out of the banks, sometimes it tends to overpredict a little bit because it's starting from where the water is and not where the channel bottom is. That's kind of an easy way to put it. I talked to Sean a little bit about this earlier. There's some exclusion here and there of hydraulic structures. It's got all the big dams in there, but if you have like a little privately developed levee or a pig farm with a pig farm pond on the guy's property, it's not going to map all that. I had a constituent from, I believe, where was it? It was in the Northeast Kingdom a few days ago, asked me, does it map beaver ponds? Well, no, it doesn't, because I know sometimes beaver ponds can let loose during high flows and you get flooding from that. It doesn't know where all those things are. So there's some of that you have to assume. You're making some assumptions in the synthetic rating curves when you have to develop these for everywhere across the nation. The last one I'll also mention is backwater effects. So it has trouble on big flows and backwater effects. So let's say Lake Champlain is a record high, like in 2011, and it goes to 103 feet. There's going to be some aspect of Lake Champlain backing up on the Missisquoi in the wildlife refuge. And in the absence of high flows coming down the Missisquoi, let's just say the lake's really high. So it doesn't account for some of that. So you just have to kind of keep some of that in mind. And that's where in the future, and I'll talk about this in a minute, when we're engaging in partner briefings or talking to you one-on-one about the reliability of this film, this is where we can talk and shoot questions back and forth between one another and say, me or one of my Hydro team members can say, yeah, I think I'm really confident this looks really good. Or like this one, I'm going to show it to you, but use it with caution. But it may be somewhere where you don't have it before, so it's better than nothing. But just understand that. And we talked about this, Sean, you and I earlier, this water body inundation. You get high flows on a big river, and I'm going to speak in our area, it doesn't really apply for us, but like the Connecticut River that's heavily hydro regulated with the big dams for flood control. During high flows, there's varying degrees of impoundment or letting the river run free through the dam, depending on power generation and public safety. There's a lot of complex decisions that Green Mountain Power and other power companies make when they're impounding this water and it's changing. Not all of that is accounted for in the water model. It doesn't know every hour how they're flipping the gates and things like that. Okay, so talking about the FIM that we're going to have available, it's been available, I showed you, since 2023. I showed you the Albany, New York area and the southern 2 counties of Vermont and a few of those areas. It's rolling out for our area in September. You're going to have 5 flavors of FIM to look at. And I'll try to keep this as simple as possible. There's a lot of reference I'm going to show you at the end of the presentation that you can read up on your own time. You've got, first of all, on the left here, you've got how we break it down by static and dynamic FIM. So think of static FIM as something that never changes. It's static, never changes. So you'll always have access to this where it's available, and it never changes unless there's like a whole scale upgrade to the mapping scheme. And then you have these 3 dynamic FIMs that change on the fly, and they're only driven during high flows. So given computer resources that were running this for millions of stream reaches across the United States, they don't turn it on for everywhere all the time. So a day like today in August, it's hot, we've been dry for several weeks, if not a month and a half or so. There's no risk of flooding today. You're not going to get these dynamic FIM maps because there's nothing going to flood. But if we're under a flood watch, or you see a tropical storm Irene coming and there's a high risk of flooding, or flooding is forecast, then they turn it on. They're also not going to turn it on for one random little thunderstorm that floods out Montgomery Center like happened in 1997 or 98. If it's just like one little thing, they probably won't turn it on because it's so small scale. You got to think of 2023-24 flooding or Irene or a bigger flood event. Okay. Because those little thunderstorms are whack-a-mole. There's a predictability level only so far. We can kind of give an idea that it may happen today, but where exactly, it's hard to predict. So you basically go, if you over here on the right, from the top to the bottom, you're going from a few points to more points to millions of miles of points. And I'm going to talk a little bit about each of these here. So let's first talk about the 2 static FIMs you're going to have available. The first one is partner FIM, and this is FIM that is made using engineering grade modeling. It's used with some water model output, but it never changes. It's the highest quality FIM. A lot of times it's derived with help from other partners, like a private consulting firm that a town would do, or the USGS will help a town or a constituency out. It includes depth information, which is unlike a lot of the other inundation I'm going to show you. A lot of the other inundation is just extent. It doesn't show you how deep anything's going to be. It's just going to say, this is what's going to be inundated. But this partner FIM will have depth information. And they've been carefully vetted out and selected over the years based off of flood impacts and data accuracy. It can also validate the dynamic FIM, since you're going to have it there as well, as a quality assurance tool. So the limitation, it's about 200 points only, but across the whole nation. The good news for us is we have 9 in our area, including some for the NRPC in your area. So we have 9 in our area. Montpelier and Waterbury have been around for a while, and we have 7 new sites on Lake Champlain. I'm going to show you how to get to these in a little bit, but toward the end of the presentation. But when you go to one of the river gauges on Lake Champlain, Rouse's Point, for example, plus these three, which are all virtual, by the way. They're not real gauges. We set these points up just to make flood mapping for it. You'll get a page like this, and you'll see all these tabs up here where you can click on the gauges. And so I have three in our area for you guys. Rouse's Point, actually there's four. Rouse's Point, which is a real gauge, where we do our forecast for the lake. Plattsburgh Bay, that's a typo, Sandbar State Park, and St. Albans Bay. These last three are virtual gauges. There's not a real gauge there, but we had to put a point somewhere and then map around it. So using this example, when you get to this page off our Weather Service page, let's click on one, SABB1, that's St. Albans Bay, just for an abbreviation. So then it takes you to this page, and then you can play around with it. The bottom tile down here is where you can choose your map projection, whether you want Street View or Google Earth or what have you. You click on these top three dots up here, and you can play around with the opacity. If you want to make this transparent, you can see stuff. And then you click your height levels on and off here, what you want to see. I've chosen 103.1, which is roughly the record stage back in 2011. This is what it's showing flooded. It's pretty dang good. And so this has utility for long-term lake planning, and the lake rises very slowly, granted. It's not going to be something like a river flood that happens more on the time scale of, a few hours or 12 hours or something like that. The lake takes days to rise. But for people that are visualizing this, and by the way, the public's going to be able to see this as well. That's why I'm reaching out to planners so that you're aware of this. If anybody comes with a question, you can either try to answer it or point them back to us, that you're aware of this is out there. But you're going to have all of this for the Lake Champlain sites around the area, St. Albans Bay, Sandbar State Park, Plattsburgh Bay. A lot of those latter points will map onto Grand Isle more than like Franklin County per se, but the St. Albans Bay one has the most applicability to Franklin County. And so that's how you get to it. I would mention there are other external partner FIMs that are out there. We don't host those on our sites. There are some that are out there by the USGS. I've highlighted some in northern Massachusetts here. There's a lot down in Houston. Some of the major metro areas, New York City, they'll develop their own FIMs for the city. It's independent of what we're doing. So sometimes those are hosted on other sites. And in some of these areas, if you're in one of those areas that has this other external partner FIM, or a town has locally done it, you can reference some of that and cross-reference, and that's where we engage and talk about it during high flows. And some of those will be very, very good because you've privately contracted out with a contractor, like SLR is an example of contractor, and make these really high resolution maps that they go around and measure all around the town. And that does happen. And so just be aware that some of those others are out there. I worked with St. Regis Mohawk tribe up in Hogansburg, New York, up by Messina last year to establish some flood stages on a gauge up there for them. They've got their own private FIM that they developed with a contractor for their little reservation up there. So I'm sharing the FIM like I'm with them, like I'm doing with you today, but I understand they've also got their really high res FIM, so they may refer to that. The other one you're going to have access to is this something called categorical stage-based FIM, static FIM as well. It doesn't change. For a short, for an abbreviation, I call it CAT FIM. It's basically tied to the actual elevations, and it's only going to be available at where we have selected sites where we have flood stages established and we have like forecasts for. So you can see here, it's not going to look, I'll show an example how it kind of looks, where you're mapping the action stage, the minor stage, the moderate, the major, what that looks like at Swanton and East Berkshire based off of, because we have established impacts for those gauges and we make forecasts for those. So they're available at 1 foot increments. And I've got them for the Lamoille. I'm going to have them for East Georgia and Jeffersonville and Johnson going on up. Yeah, exactly. We do have some QC on there. So I do have the ability to not share it if it really stinks. From what I've seen, there's still some work to be done at Swanton. East Berkshire looks really good. Georgia looks fine. But it's improving all the time. So I have high confidence that the Swanton stuff will be able to come online within the next year or so. When we go live in September, I'm not positive that the Swanton stuff's going to be online yet. but we're going to have some back and forth when we turn this stuff on. I'll be putting out an email to everybody on who I've been engaging with to look at this. Because sometimes, you don't want to put something out there where the public can see it as well that's not accurate and falsely lead somebody. But on the other hand, you do want to show it where it could add value. So basically, and I'm going to show you how to do this at the end of the presentation. You basically you click on the Swanton gauge on our river page, and you scroll all the way down the page. And when you click on the river gauge, if anybody's been to our site, you'll see the hydrograph. And then if you scroll further down, you'll see this like little map where the gauge is located. And then right below the map is this little radio button here, activate or deactivate categorical film, right down here. And you just click that on or off, and then this appears. This becomes clickable, and then you just click on it. So we're not live in our area yet. I just chose some random point in Anywhereville, USA. I turn this FIM on for this point, ATOT2. T being the state identifier, so Tennessee or Texas or somewhere like that. And then you click on this, whatever you want. This is what the moderate stage threshold looks like. You play around with your opacity down here. You can zoom in and see what floods. Okay. And so again, CatFim, it's only going to be on your forecast river points, basically. So we've got a gauge up on Jewett Brook as well, but I don't have forecast for that. It's just a little gauge. I don't have CatFim for that because I don't have any flood stages for that. Jewett Brook doesn't really flood anything. It's kind of right by Lake Champlain, and it can come up a little bit and down, but if you look, it doesn't really inundate a lot. Unlike the Missisquoi, which you can have flooding for. So this is just a little animated movie. It takes a little while. I won't spend too much time on this, but this is how we define action stage. It's basically reached when it reaches the bank full. And so when things are rising to action stage, prepare. Minor stage, where you start to have some minor impacts. Maybe a few dirt roads are affected. Certainly farmer fields flooded. Some inconvenience. And then you go to moderate stage. This is where you start having, and we define these. It's kind of, we work with communities, and these can always be tweaked. This is where secondary and even sometimes more significant roads are flooded. And then when you get up to the major stages and stuff, this is where like you got evacuations and things like that happening. I would note, and this is kind of outside the context of what FIM is saying, but in 2018, when I worked with Reg and Swanton, it doesn't take into account ice jams either. I mean, ice jams are kind of like this whack-a-mole. You don't know where they are, and they're dynamically changing by the hour. This water model doesn't know that. So you get a big ice jam on the Missisquoi and you got problems in Swanton, that's where we're giving out briefings and talking to each other and stuff like that. So that's kind of how it's mapping and kind of how we define action, minor, moderate, major record stages. So those were the static FIMs. Now let's move on to the dynamic FIMs. So there's going to be 3 dynamic FIMs when we're under high water that you're going to be able to see. So the first one I'm going to talk about is the National Water Model 5-day max forecast FIM. So when we're going into high flows and they see it happening 5 days in advance of Irene coming up, and we're going to probably be hit, it gets turned on. This is what the water model is thinking is going to be inundated. Okay. This is updated about 4 times a day with new model data. And it's basically based on this national blend of models rainfall. Basically, they take a lot of weather models, a lot of outputs, they throw it in a blender, they get a mean and a mode and a median, and they feed it into the model. It's the best way to minimize the error in your precipitation forecast. If I just chose one model that looks good to me, I may win sometimes, but over the long run, I don't win on that. Blended stuff works better. The high water thresholds vary by region. This is just a publication. This is a link to what they use. It's based off of something called water year runoff efficiency variability. But believe me, I don't fully understand that. It's a little above my head on that. The main point is when high flows are predicted that are unseasonably high or we have flood watches, they turn this stuff on. The one limitation of this is they're turning it on theoretically for multiple states and multiple regions. There's no quality control on the fly when they run these things. So of course they can tweak this model yearly and monthly outside the context of high flows, but daily when this thing is running for an area, There's not a person in there tweaking this for every little stream and river. I mean, you would need a million-man robot army to do that. So limited quality control. So when you go to our river gauge, and again, I'll show you how to get to this. When you go to our water site, before you even click on a gauge, you come down here, you click on flood inundation, and you're going to get a little pull down menu right here, and you're going to be able to click one of the 3 dynamic FIMs. So I've chosen NWM Max Forecast FIM, and then this is what shows up for you. And then you just zoom in, and you can play around with the opacities down here. If you go up higher, there's a hamburger tile where you change your map projection. So dynamic FIM, and that's the 5-day National Water Model. The other dynamic FIM we have, number 2, is the River Forecast Center. They're the guys gals down in Boston that help us forecast the rivers, and then we push it out after we coordinate. It's similar to the water model 5-day max forecast inundation, but you're only doing it down to where they forecast the rivers. So whereas that water model was everywhere, this is just going to be downstream of East Berkshire and Swanton and East Georgia on the Lamoille River. Okay. And that's where, when you're forecasting high flows, bank polar action stage or higher, or under high flows, they'll turn that on. So again, there's value in this. There's values and disadvantages. The disadvantages, what are the disadvantages? You only have it for 2 or 3 places, right? But it's in Swanton, so it's where people live, so that's good. The limitation is it's only available at these points. But another good thing is this is the official forecast based off of what they think it's going to be. So the FIM's already mapped out, and they're going to say the Missisquoi River at Swanton is going to go to 21 feet. Well, what does that look like? Because that's the official. So that's the value of that. There is some engagement with what that forecast is as it gets put into the water model. Again, you get it the same way. You go to the river page, you click on flood inundation on the side menu, and then you choose your flavor here. In this case, the max 5-day forecast. And then you can zoom in. I chose the Potomac River at Harpers Ferry, West Virginia as an example. And this is an example I just handpicked out from a few months ago, and it'll show you what theoretically floods based off their forecast. The last one you're going to have is the National Water Model, again, dynamic latest analysis film. So it's similar in many respects to the first one I showed you, the 5-day max film. There's no QC, all this stuff. The nice thing about this is it runs every hour. The latency is about 55 minutes. So if it runs at the top of the hour here, let's say at 10 a.m., you're going to get it right before 11. It takes time to process the model. So there's, give and take with a little bit with that. So if you have poor data, or you don't have gauged areas, or you can't tune into the observations, or the radar data is not that good, there can be some disadvantages to it. But it's FIM where you've never had FIM before, and it's updating every hour. Again, the high water is threshold by region, but if those other 2 are turned on, this is going to be turned on too, and you're going to be able to look at it. Again, not to beat a dead horse, you get to it the same way. You turn on flood inundation, you choose this one. And then you zoom in. I've got a different map projection and opacity on this one, but I think this is Mississippi River down in western Kentucky and Missouri. And you can see what it's trying to inundate. So the strengths of the National Water Model and the RFC FIM, again, going over these, you can visualize flood forecast and impacts across every river across the nation. You get a common picture of the river stream flood threat in a given area. You can put that water on a map and cross-reference to that for what the flood warning means. They're forecasting moderate flood. This is what the FIM looks like. Or we got a lot of rain falling. What is Jewett Brook doing? What does that look like? You can improve the ability to target areas and pre-position resources, especially from a regional or a state level. Maybe not at a local town level, but depending. A lot of this has already been put into action with some of the recent devastating Texas floods, with all the loss of life down there, and in some of the spring really bad flooding in Kentucky and Tennessee and Missouri that they had back in the spring. And you can use it certainly for large-scale regional and national response with FEMA and swiftwater rescue teams and things like that. So when you have a big flood coming up, we did a July 23 again, state EOC is activated in Waterbury, and they deploy Mike Cannon's group in swiftwater rescue, and we're trying to target where we want to go. This is the type of stuff that we could actually have a lot of benefit. And we're all talking, even with the, the regional planning committees in the local towns as well. And this is a random quote from not our area, but from somewhere else. It could have been helpful. You had a lake flood. Oh, the lake flood. Yeah, absolutely. Because you have planning time for that. And Sean and I were talking earlier, realistically, Reg has been in Swanton for many, many, many years. He knows kind of what floods when it gets high there. So some of this may be old hat for him when he sees it on a map. But think of anybody else that's in the department that hasn't been there a long time, or your people are going to be publicly able to see this, a private residence. Your next door neighbor can see this. They may not, know what that means on a map. So I think it depends on the level of expertise and experience, and from planning purposes, it can certainly have value. So some limitation, again, on this NWM water model and RFC FIM, this is extent only. I touched on that earlier. There's no depth. On the partner FIM on the lake that I showed you at the start, that static FIM, that has depth. But this is not currently being, showing depth. It's just extent. So you're not going to be able to say it's 2 feet or 1 foot or 6 inches deep at this building location. You're just going to say that the model is inundating that. It is limited to the degree of the LiDAR resolution, which is 10-meter digital elevation model. So you think about that. So you can't see the really small physical features and their impact on the FIM, such as a small ridge, a bridge, an unofficial levee. Bridges are getting incorporated into it as we speak. There's a new model update coming out next month. But some of these small little features may not be totally taken into accounting of. You've seen this before when a place floods on a river, for example. Sometimes it's not intuitive, right? The flood doesn't necessarily come straight from the river right across to the house. It may back in from the other side or come in from a drainage ditch from the north or south and back in that way. So some of that sometimes cannot be totally depicted right. And then, of course, it's based on some simplified physics because we're mapping this for the whole nation. And we already talked about that with the hand method. Of course, it's limited by how good the precipitation forecast is, right? If the model's precipitation forecast isn't that good, then the water model inundation won't be as good. So it all depends on some of that. The way we're doing it now is minimizing the error as much as possible. And that's the best we can hope for right now. Again, these water model versions, they have no human influence on the forecast. So they're not adjusting the precipitation and all this kind of stuff. And that's why this is just one flavor. And I always want to circle back to this. This isn't the end game. Of course, 5 inches of rainfall in Montgomery Center, I'm going to put out a flash flood warning alert, and it alerts on your phone or gets a scroll on TV. That has to be taken into account on some of these things. So you have to kind of incorporate all of this together. I'm not going to talk too much about coastal use, just to point out that they're still developing a lot of the coastal FIM because there's some challenges when you're routing high flows down a river, the Hudson River going into New York City and flowing into the Atlantic Ocean, and you have a storm surge coming up the river from Tropical Storm Irene. That's very complex to say what the river height's going to be. But they're getting there. So, but we don't have to deal with the coastal stuff right now. Hopefully not in a long time unless sea levels rise 100 feet. I touched on a little bit of that. A lot of the big reservoirs are incorporated into this, but a lot of these little impacts on these reservoirs, depending on what they hold back and let through, are not totally modeled. So we have to take that into account. And so you can see on the map, Lake Champlain there's some limitations on what the water model can map. That's why the partner FIM for you guys is so great, because you got it on the lake. And that's why we did an effort over the last 5 years to get partner FIM for the lake. Because the water model, these big water bodies, some of them may have a harder time modeling some of this on all the flows coming in. But you got the partner FIM, which is the gold standard. So that's really good. Okay, moving on and talking about partner FIM and IDSS as we get toward the back end here of the presentation. IDSS, Interactive Decision Support Services. I throw a lot of acronyms out, but that's kind of what we use. This is just basically a timeline from left to right showing how you could theoretically use this. So we have the first kind of tier here, the day 4 through 7 pre-planning. You're going to have the CAT FIM. I should have changed this. This is another talk, but realize that you're going to have this for the Missisquoi, for the cat film, East Berkshire, and hopefully Swanton soon. And you definitely have the partner film. So ignore what the actual annotations are here. But the main point is, as you get closer and closer to the flood event, you have access to all of them. Because as you get close, within 1 to 3 days, we're forecasting high flows and flooding. Then they turn on this dynamic film for all this stuff I just talked about. And then when you get into the post film, some of it starts being turned back off. That's kind of how you kind of plan in advance. So you guys are going to have the partner film and the cat film always. And then you get the dynamic film basically as you get into the flood event. And then as you move out of it, it starts getting turned on. And these are just some general ideas. Some of you may have seen our emails that we send out to partner constituents during hazardous weather. Town emergency managers and people get those. You can subscribe to those lists if you want and get these. We mainly geared toward public safety and planning. We don't send these out to the general public. But just some examples. I got an attachment of, here's an attachment of a hydrograph with the impacts, and this is what it looks like. And so there's different tiers of levels that we can do these decision support. That would be an example of a baseline IDSS. So we have the public services. Everybody's going to see the river gauge and look at the film. And then the baseline decision support, this is where we're sending out like an email, a more targeted one. And then real targeted IDSS, which we can always do for search and rescue on Lake Champlain. Train car, propane tank train car overturns in Swanton and spills chlorine gas. We can target IDSS just for that. These services are available from us. And then finally, the big dogs like the integrated. So we're at the EOC during Irene, state level EOC, and we're one-on-one briefing. There's levels that, 95% of them are these two here. And then these are the more targeted, especially an example that we do targeted DSS for, we're embedded at an EOC is like the Vermont City Marathon. We're there for heat thresholds, or we can have a big event planned. Like sometimes we've gone to the Champlain Valley Fair when you have thousands of people in the grandstand. We were providing targeted DSS for that. Again, just an example of a baseline or a targeted DSS for a town where we can show them the film, what our official crest height is at a gauge, and highlight an area that may be shown susceptible to flooding. Here's one that was shared last year when Hurricane Helene went in and devastated Western North Carolina. If some of you remember, Asheville was devastated. Went to record flood on the river, and we were sharing film output with them and showing what. This is a very high-end case where the whole city's inundated. So it certainly can have applications to that. But even on smaller events, it can have some applications. So the last here, I'm going to talk about some tools and resources, and then I'm going to again go to show you how to get to the dynamic and FIM and things like that as we kind of wrap it up. So just as in recap, you're going to have coming in September, the categorical stage-based FIM at East Berkshire and Swanton during high water, and Swanton with an asterisk because I'm not totally confident it's going on right in September, but hopefully soon. And we have the partner FIM at those 4 Lake Champlain sites I showed you that'll affect Grand Isle or Franklin. And that's always going to be turned on, that partner FIM. I don't know why I wrote during high water. The cat-based stage-based FIM is always going to be turned on. That's a typo. And then the 3 dynamic FIMs at the bottom, which are during high water. So that's the latest analysis FIM, the one that runs every hour, and then the 2 5-day ones. Okay. There's other services you can get that I didn't even go into that don't have anything to go with FIM that I just throwing in there because these are available on some of these platforms, and they include like probability of flooding and arrival time and things like that. I'm not going to get into all of that. I would mention that there are visualizations through our normal water.noaa.gov platform and also something called the National GIS Viewer. That's another platform that you can access these services. I'm going to share the digital handouts with Sean later today or tomorrow so we can share them with you. I brought printouts here, but it'll show you how to get through there and access some of the data. I'd also mention if you have your local owned GIS platforms, we have REST services and API services to import the FIM into those. And some local towns have their own GIS platforms that they run off of. The state level has VCGI, if you're familiar with that.
Yeah.
They're going to pull some of this into that you can visualize some of that, in addition to just being able to visualize it off this public way that we show it. So I did want to mention that for the GIS API gurus that want to play around with it, you can pull that into your own data sets. And again, this is just kind of takes you to some of this and how you can pull it in. This cloud web GIS web-based services URL. And this is a web page that will show you a lot of what I talked to you about today. If you go to here, there's different things about water, because the National Water Center does everything water, but this bundle talks all about the FIM, some of which you can see that I talked to you about today, stage-based and stuff. There's some fact sheets in there, how to visualize the FIM on our viewer, which I'm going to show you in a minute. But you can view the online document yourself in your free time. When you go to the national viewer, that other website, it's very similar. It looks a little different, but you scroll down and you have to turn the FIM on down here. It's pretty straightforward. And again, you go to the nationalwater.noaa.gov site, which I'm going to show you here in a minute. You click on the flood inundation here and you can go around. And so you can do a lot of this stuff with linking the hydrographs to the FIM and referencing back and forth and evaluating its validity and its usefulness depending on what's happening or for planning. So it definitely has some uses. I would mention that for any gauge, you always have this water model guidance that you can see the CFS based off of what the water model runs. And I can show you where to go that here if we have a minute at the end of the time. This is not really related to FIM per se, but for any gauge or any stream reach, you've got this. It's just not mapping the FIM, it's running the flows. So before we get to any questions, let me, I'm going to back out of this real quick and I'm going to go to our website here. And I think most of you have been here before. Can you see this screen now that shows our website? Could somebody confirm that?
Yes.
Yep.
Okay. So if anybody been to our website, to get to the river gauge data, you just click on rivers and lakes right there, and it takes you to our river gauge site. Okay. So if you zoom into your area, here's all your little gauges. The ones with the squares are the forecast points. So see Missisquoi River at East Berkshire. Here's Swanton. Here's Rouse's Point. Here's some of these other little gauges, Jewett Brook, Rock River. But you've also got the partner FIM on these Lake Champlain sites. So to get to that, and these are virtual, I mentioned this is not a real gauge, but you click on that guy, and then you click on full gauge page. Normally, if it was a normal river gauge, it would have your hydrograph right here, but it's not a real gauge. So there's nothing, no data being collected. Then you scroll down under this unique local info right here and click here for FIM display. This is for your lake sites. Unique local info on the full gauge page. So you click there, you click on the new window. You say, I agree, this is for planning only. And then this is the site I just showed you, right? Let's go to St. Albans Bay. And where you change the map is under this, my little stop sharing screen. But I can't see it, but it's underneath. Trust me, it's under this. And then here you change the transparency of your FIM, so you can play around with it. And then here's where you come in and let's just choose that record level. And we can zoom into St. Albans Bay. But you can see, like, it's, when the record flows, it looks like it tried to, this is a low point between the islands here. Or between the, some of the islands here, Burton Island and some of these areas. But that's how you visualize the FIM. And it's the same way with any of these other sites. So if I went to Sandbar State Park, it's going to map for Sandbar now here on the Lamoille. And that's mapping at what 99 feet is. Let's go to 1031, which is the record flooding. Again, just how I mentioned before, this is the better stuff mapping. Like if I were doing dynamic film in this and the lake was really high, remember how I talked about how like backwater is like I'd want to be cross-referencing some of this partner film with the dynamic film, because some of this backwater that could be pushed by the high lake back up this part of the Missisquoi, you may have to kind of compare that a little bit to see what looks reasonable. And that's how you visualize the lake film. Okay. So that's your partner film for the lake. Let me just go ahead and close these windows out, and I'm going to come back to this window. Now let's go to cat film. That's going to always be turned on when we go live in September. And as you recall, Albany already went live back in 2023. So let's take a look at the Walloomsac River at Bennington, North Bennington, Vermont. So I click on their little gauge here. You see the little hydrograph. Click on full gauge page where you see all the impact statements and all that kind of stuff. And it loads this. And if you go down below where the river gauge is, let's change that. Let's go to a satellite. Right down here, activate cat film. It turns it on for you. And then you can play around with opacity. And you can like whatever you want to see. Yeah, I think it just defaults with all of them on 1 foot increments. So this is moderate stage threshold with this. So, you know, it depends on what, and I have the ability to turn some of this on and some of it not. It just depends on what, you know, minor flood stage. I can play around with what that looks like. But that's how you're going to be able to see East Berkshire and East Georgia on the Lamoille, and hopefully within the next year, Swanton on the Lamoille, and play around with these flood stages for the cat. Again, that's static. It's never going to change unless they do like a big model upgrade. It has nothing to do with the dynamic film that's running. Okay. So now let's go to see dynamic film, and I'll just show you that real quick. So we have no flooding by any means in our region. So dynamic film is not pulled on, is not turned on. So let me zoom way out and go somewhere where we have some flooding. So here's some flooding on the Missisquoi, or action stage out here. And so what we can do is we can turn on this gauge, but even easier, what we can do, since it's turned on, is right here on the map over here, there's 2 pull down menus. Oops. Pull the inner menu down and see flood inundation right here. You click enabled. Okay. Turn it on. And then here is where you choose your dynamic film if it's running. And then you come in here and you have to zoom in to be able to see it, and then it turns on for you. So here's the National Water Model 5-day max film at this little river gauge, Mississippi River at Louisiana, Missouri. And if you scroll down, the only thing that I don't like about this is if you want to change your map projection, you got to come back up here and turn satellite on and then scroll back down again. And then you can play around with your opacity here. Okay. These grayed out areas we don't have to deal with, just for the sake of this point, since it's turned on today. As you likely know, the Mississippi River is heavily levied, big levees, big flood walls to protect stuff which have been in effect. So that there's an option to turn the levee information off. Okay. The emergency managers in these towns would know, like, this at this level, this isn't a flood. Okay. Levee's going to protect us, but good to have them in. And then you zoom in, and this is what the water model says the max day extent's going to be. And so if you see that, you can say, hey, well, you know, this looks like I looked at this earlier. This is the water treatment plant. And this is the town highway garage. So that's a public infrastructure that would have impacts based off of that. And some of these low-lying homes down on these avenues. And this, you know, you can see, well, this part of town is not going to be really affected. And so, you know, the town emergency manager may know a lot of this, but he may not know the exact extent. So it's, you know, you can visualize that and at least get an idea of what that would look like on a map. And then all you do to change your film is you come and you change it. And you have to change the opacity. And it's a little different take of what the RFC film looks like. It just depends on what you're looking at. And so those flavors would change if they're running. So that's how you get those dynamic films off our national site. And that's how you would do it. It's going to disappear as I zoom way out, but that's how you would do it in Vermont. You would just turn on the dynamic film and you would zoom in and it would turn on for you. And then you play around with the opacity. So that's all I got. Let me stop sharing my screen and then I will take any questions from any of you that you had on that. Yeah, I encourage people to play around with it in your full time. And those references I gave you, some of those links where you go in there, I think the one that took you to the national page where I ovaled some of the data where you can, the visualizations I just showed you, there's a link in there that says view on NWPS, which is that platform. And there's instructions on how to do what I just showed you. Because I'm not expecting everybody to remember everything. Just remember when you go to the water.noaa.gov page, you got to scroll down and turn that film on for the dynamic film. And to access that partner or that static film, you got to go to the full gauge page, like click on the gauge and then click on that option under unique local info for your lake sites or under the gauge map on the Missisquoi River, turn it on or off for that cat film, which those will always be there for you. No, I appreciate it. Thanks for the positive comments. Again, it's going to be one layer, you know, of several when we talk about flood hazards and planning and stuff. But it's certainly something better than we've had before. It's something that we've never had before for a lot of these areas.
Hey, John, I just want to make sure I understand. So we looked at the static map for the Albany area, right?
Yeah.
And we had to click on a river gauge to get to that.
Right. You
Okay.
click on the river gauge, and remember it's cat film chip, so it's
Yeah.
based off of stages of flood impact. So if you clicked on the full gauge page for Jewett Brook, it's not going to have an option for that because there's no flood stages for that, even though there's a gauge there. You're going to have to click on that for the forecast points for that cat film. But you're exactly right. Click on the gauge, then go full gauge page, which is at the top that shows everything. And then scroll down below the map of where the gauge is, and there's the little radio button you turn on and off.
All right, thank you.
Yep.
John, I think this is outside NRPC zone, but we are the whole Missisquoi. So I think I'm correct in that North Troy also has that forecast, right?
North Troy will have it. We've got flow coming on right now, and I think North Troy will be live in September. We're working out some mapping things as well with that one, but I'll let you know.
Great.
Because I'm QCing all this. There's a few, and the majority of them are going to be turned on. There's just a couple where I want to be careful. Another one, just for example, is the White River at West Hartford going down into the Connecticut. There's some goofiness in there where, remember I told you about the bathymetry on some of them, that it doesn't map some of those lower stages quite right. The major and the moderate stages for that gauge map really well, in my opinion. But the minor flood stage, which should be just nuisance stuff, is actually flooding some homes, which I don't think is right. And I don't want people to see that and get scared. So, and that's a case where we're going to be working with the River Center, and it may have to have some follow-up on what I actually turn on that. But that's in the minority of what's going to be available. No, thanks for your question, Lindsay. That's a good point.
Yeah, well, thanks for this presentation. To echo Sean, I look forward to playing around with it.
Yeah, well, absolutely. And you have my email address. So out of the context of this talk, if you have any other related question that I may not cover here, just email me. I'll get back to you.
Thank you so
If
much.
you can't find one of those links or something that you're trying to navigate to find where the instructions are, I can find those right away for you.
Great.
And maybe along those lines, if there's a way to have an electronic version of the handouts that you brought with you, you know what I mean? If you can post those, or maybe Sean, if you could send out a version of them.
Yeah, I can PDF them at the office and send them out.
Yeah. What I'll do, Sean, is I'll send you a couple of the main URLs to go to for instructions, great. And then I have digital PDF handouts.
Okay.
PDF versions of these handouts. Importantly, like how to get, if anybody wants to ingest it into your GIS services, there's instructions in there. I'll give you that, because I'm not going to cover that right now because that would take a half an hour in and of itself, how to do that. But no, excellent question. I'll do that. I'll follow up with Sean later today or tomorrow and get that stuff to you. Okay, well, I guess if there's no more questions, hey, thanks so much for your time, everybody. And again, follow with me if you have any other questions. I'll get back with you, and maybe there's an opportunity in the future where we can talk to the town and other planning communities or
Definitely.
emergency responders.
Yeah, we'll be more targeted to that. We have some new emergency instructors
Okay,
in the region that are always, so,
sure.
especially in the islands.
Oh, great. Well, I'm sure they'd like to partner with them for the islands to see that. So.
Yeah. And we'll have, for everybody that's here too, we've recorded the session and we'll have it up on our YouTube page, channel, whatever it's called. We'll let you know when we get it up there.
Super. Well, thanks again, John, and thanks, Sean, for arranging this. Really appreciate the chance to learn more about this. I'm excited about the possibilities.
All right, great. Thanks everybody for joining. Great talking to you today.
Thank you.
Have a good rest of your day.